Today's learning target is I can solve problems using the rate of change. Today we're going to be talking about rate of change. And the rate of change is how one quantity changes in relationship to another. So let's take a look at what that means. So over here we have a graph that shows the height that a kite surfer gets over any given amount of time. So if we wanted to find the rate of change from point A to point B, this would be the starting point until 4 seconds in. Here's how we would do that. We're going to take the change in height right here and we're going to divide that by the change in time. So if we went from point A, which was the starting point, to point B with 4 seconds in, we can see that at the start he was at 0 feet in height, and after 4 seconds he was 4 feet high. So he ended at 4 feet and he started at 0. Okay, so the change there would be 4 feet, and we're going to divide that by the change in time. So after 4 seconds, I'll put an S there, he started at 0 seconds, so the change in time was 4 seconds. So if I divide that, 4 divided by 4, that's going to equal 1 foot per second would be the change, the rate of change from point A to point B, or from 0 seconds to 4 seconds. To find the rate of change from point B to point C, I do the same thing. So I do the same thing here. At point B, he was at 4 feet. At point C, he was at 10 feet. So to find the difference between those two, I just have to do 10 feet minus 4 feet, and so that is going to be 6 feet, and I'm going to divide that by the change in time. So I take a look here, the change in time was at 4 seconds, and here it's at 6 seconds, so I find the difference between 6 seconds and 4 seconds, subtract that, and that would give me 2 seconds. Now I do 6 divided by 2 would be 3 feet per second, and that's the rate of change from point B to C. Now I could see from C to D, the rate of change is actually going to be 0. There's no change there, right? And I can see from D to E, if I did that, the rate of change would be a decrease. So instead of an increase, here was an increase, here was another increase, here there was no change, and this would be a decrease of the rate of change. So he would be descending or going down a number of feet per second. The thing to remember when doing rate of change problems is that you will always put your change in the y-axis on top and your change in the x-axis on the bottom. So later in this unit, we'll call that change in the y-axis the rise, and we'll call that change in the x-axis the run. And we'll explain more about that later in this unit. But for now, just know that when you're doing rate of change, the change in the y-axis always is your on top, and the change in the x-axis here is always on the bottom. We can also find rate of change from a table like this. So let's say this table shows the biggest drop of the Wild Thing roller coaster.
So let's find the rate of change of the biggest drop, which when I look at this chart here, looks like from here to here, looks like it drops about 200 feet. So that's going to be our biggest drop. Now remember, when we're looking for the rate of change, we're going to look and we're going to do the change in the y-axis over the change in the x-axis. So to find this rate of change, I'm going to take the change in my y-axis. Okay, so here's my y. So I'm starting with 456, and I'm going to subtract 268 from that. Okay, now I'm going to take a look at my change in the x-axis. Now I started with this top number for my change in the y-axis, so I have to start with this top number here. So I'm starting with 0, and the change is 1. And when I subtract this, I get 188 on the top, and the bottom I get negative 1. Okay, so that's going to equal the same, or the rate of change, I should say, is going to be 188, and we're talking feet, per second, but it's a negative, right, because we had a negative 1 here. So we are when we look at that, that means we're dropping, it's a negative, we're dropping 188 feet in 1 second. And we can see that in this table here. Now oftentimes kids will have the question and they'll say, well, does it matter if I put this number first or this set of numbers first? And you can see I've done that right here. It actually does not change our answer any. The only difference is here we had the -1 at the bottom, here we have the negative at the top. Either way, it's still going to be a drop of 188 feet in 1 second. So for this one, we would write our answer like this after showing our work, a decrease of 188 feet per second. And again, this is the way you would show your work, so make sure you do that in your work today.